Hello, welcome back to the channel. So let's do one more word problem on differential equations. So in this question, we have been given that there is a tank which is of height 2 meters and it is to be made with circular cross sections of radius r equals y to the power p, where your y is basically the vertical distance from the bottom of the tank. So for example, if this is a tank which is of height 2 meters, if you have to calculate this radius over here, which is from this point to this point, if you have to calculate this radius, it will be basically the height from the bottom. So whatever y you'll have, you'll basically plug it in this equation to calculate the radius at that height. And we have also been given that p is a positive constant, and accordingly this is the differential equation which has been provided to solve this question, where a of y is basically the cross-sectional area of the tank at height y. So since you know that the tank is made with circular cross section, so the area will be the area of the circular strip over there of radius r. So we know that if we have to calculate ay, it will basically be pi r square, where our r will be y to the power p, right? So we already know what ay is, so we can solve for our y in terms of t from this differential equation. But in this question, you have to calculate the value of the positive constant p with this given information over here. So you have been given that the time taken for the tank to drain from y equals 2 to y equals 1 is exactly the same time which the tank takes to drain from y equals 1 to y equals 0. So based on this given condition, we have to calculate the value of the positive constant p. So now let's first solve this equation over here, because if we solve this equation over here, we'll get y in terms of t, and then we can play around with this condition in order to solve for our positive constant p. So now we know that in this case, since ay is the area of the circular cross section, it will basically be pi r square, where our r is basically given by y to the power p. So if you'll solve this, it will be y to the power p square, and this will be pi y to the power 2p in this case, right? So now we have our ay. We can plug it in the differential equation we have. So it will be pi y to the power 2p dy by dt equals minus c root y in this case, right? So now, since this is a separable differential equation, we can separate out the similar components on one side. So we can have y to the power 2p upon root y dy on one side, have minus c by pi dt in this case, right? And now we can integrate both sides and solve for these two indefinite integrals in order to find the final answer. And also, since we know that we will be calculating these indefinite integrals, we'll be adding a constant of integration. And in order to calculate the constant of integration, you know that when your time is equal to 0, your tank is just about to drain, right? So when your time is equal to 0, your height is, your y value will be 2 meters, right? So we have been given that y of 0 equals 2 in this case, where this means that when your time is equal to 0, your y is equal to 2 in this case. And based on this initial condition, we'll be easily able to solve for a constant of integration. And if you'll solve your differential equation, you'll get this integral over here, which is the same integral as this one. So if this is your constant of integration, which they have denoted with small d, you know that at t equals 0, the height is y equals 2. So if you'll solve for your t as a function of y, or vice versa, you'll get this equation over here. And the reason why we chose to have t in terms of y is because of the condition given. We know that the time taken for our tank to drain from y equals 2 to y equals 1 is the same time the tank takes to drain its water, to drain its liquid from y equals 1 to y equals 0, right? So now if we have our time in terms of y, if we have a t function in terms of y, we can use the condition given. So we know that the time at which the height is 1 is simply obtained by substituting y equals 1 in this equation. And similarly, if we have to calculate the time when y is 0, we'll again plug our y equals 0 in this equation to get the time, right? So now based on the given condition, we know that the time difference from y equals 2 to y equals 1 is the same time difference which is from y equals 1 to y equals 0. So we have this condition over here, and if we'll substitute all these y values into this equation, into the equation over here, we'll easily solve for our p in this case, where our p would be simply equal to 1 by 4 over here. So p equals 1 by 4 will be your final answer to this question over here. So that's it for this video. Again, the main takeaway from this question is you have to first identify what your favorable function is, if you want your y in terms of t or if you want your t in terms of y. Since in this case we were playing with the time values based on the given condition, we found it to be easier to have our t function in terms of y so that we can easily solve for our p value, right? So in these type of questions, you have to first identify based on the given condition what will your favorable function look like. And then the rest process is about using the initial condition or the given condition to solve for your answers. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.